Alright, hi. So in this video, we're going to show that a function between vector spaces, uh, how to show that this is not a linear map. So recall a linear map is a function between vector spaces that preserves sums and preserves constant scaling. And so what we're looking at in this example is S, a function from the polynomial space to itself, that takes a polynomial and maps it to minus 4x plus 4 times that polynomial evaluated at 5. So our contention is that this is not a linear map. Now, the sort of giveaway as to why it's not a linear map is this minus 4x. Whenever you have a linear map that just tacks on vectors inside of your space and just adds those ons, that's kind of a sign that um, something might go awry. And we'll see why in this case. But for now, what we want to do is show that either this condition or this condition fails. And we once again remind yourselves that it doesn't have to fail for every single v and w. That as long as we can find any v and w for which that fails, that'll work. So let's go ahead and address the first condition. And so what I need is to show that s of f of x plus g of x is not equal to s of f of x plus s of g of x. Alright, so far so good. And again, we don't need to do this for every single f and g. If it fails for any f and g, that'll work. So let's pick some f and g's and see what happens. So we're going to let f of x be x squared and g of x should be, I don't know, 3, I think. I think this will probably be fine. And so let's see what s of f of x plus g of x is. Well, that's s of, x squared plus 3, which according to my action is minus 4x plus 4 times 5 squared plus 3, right? What happens when I evaluate the polynomial in question at 5? So I'm going to end it with minus 4x plus 112. Alright. In a similar spirit, s of f of x, which is this, is just s of x squared. And s of x squared is minus 4x plus 4 times 5 squared, which is just minus 4x plus 100. And s of 3 is going to be minus 4x plus 4 times, 3. And that's just going to be minus 4x plus 12. And what we can ask ourselves now is s of x squared plus 3 equal to question mark minus 4x plus 100 plus minus 4x plus 12? And answer is 100. That is technically what we're asking for. Let's write this out all the way. And well, when I look at this, I can see no, right? Like, sure, this 12 and this 100 make 112, so that's fine. But I have a minus 4x. For that minus 4x, I have this extra minus 4x here. And so this goes back to what I said before, when you have a transformation that just tosses constants in as summons, then every term in the summand contributes its own minus 4x. I have 2 minus 4x's on the right here. I only have but the one on the left, this is not going to work out. So emphatically, we can say, no, that's not the same. S does not preserve sums. And is not a linear map. Alright, so that would be good enough to show that this is not a linear map. But we should adjust the constant case just to see what that looks like. So if I were to go about this looking at constants instead, I could say that I want to show that S times C of a F is not equal to C times S of the X, right? So I'm going to go ahead and do that. I'm going to let C be 2. And let's use the same F as before. There's no reason to reinvent the wheel. And let's ask yourselves, what's S of 2x squared? That's 2f of x, or C f of x, right? Well, S of 2x squared is ostensibly minus 4x plus 4 times this polynomial evaluated at 5, which is 2 times 25. So we end up here is minus 4x plus 200. On the other hand, 2 times S of x squared is equal to 2 times minus 4x plus 4 times 25, which is 2 times minus 4x plus 100 equals minus 8x plus 200. And once again, we can see very clearly that these two things are not the same. Right? And again, it's this 4x that plays the role here, right? This thing, when I evaluate my vector, I get a minus 4x term. But if I scale that at all, I'm scaling the term that I add in this case 4x, and now I have double that, minus 8x, and these two things are not going to match up, right? So what we see here is that S does not preserve constant scaling, and is not a linear map. Alright, thank you very much. I'll see you in the next video.